Hello, welcome. I messed up something in the recording, so I'm just going to redo the session briefly and just do a little walkthrough of what I did alone, talking to myself a few minutes ago or over the last couple hours. Our focus is this basic interpreter, and we're doing some work on a debugger view that shows the variables that you have active. And in particular, we want to show the contents of the array variables. We have the regular variables working. So let's walk through what we did. So the bulk of it is in in value. We had the notion of arrays, and the way it used to be was the array value contained the list of dimension sizes, the contents of the array, and the type. And what we did was we basically created a new class, BasicArray, that holds that stuff for us. All the places that used those specific fields before, they've all been changed to use the basic arrays. And the big place is really in the interpreter. So here's doDim. When you create it, it creates a basic array of the dimension sizes and the type. Okay. This one defaults the content to the product of the sizes and gets the default value. Okay, so just zeros if it's a number and empty strings if it's a string, and stores it. Okay, and then the other two places we had a fetch and an assignment. So I think this is the assignment. Yeah. We were managing all that stuff about the dimensions and the contents and so on. Now we just say basic array put indexes, which is the array of integers, giving the index key, the indexes of the array, multidimensional array, and the value. We also pass location. Actually, I want to get rid of that. So let me add that up here. Remove location from array methods. The reason the location is there is if something goes wrong, we want to put an error message out, like maybe index out of bounds or something like that. I still have to return the error, I think, but I want to decode it here and let this thing know about the locations. The array itself has no notion of locations and doesn't have one and shouldn't have one. Well, it does have one now, but we pass that in, but it shouldn't do that. Okay, but here's the put, and then there's a get. Let's see. Array.get. Okay. So when you fetch an array value, we look up the name, and if there is none, then we dimension one. We make sure you're not subscripting a plain old variable, and then we evaluate the indexes. So if it's a sub 2 comma 3, then 2 and 3 are easy to evaluate. But if it's a sub x plus y comma z times w, we have to evaluate those expressions. We get back some what we call values, which would be numbers in our case. And then we ask the array, hey, get me the value at these indexes. And again, we got this location if there's a problem. All right, and let's go to basic array. The big thing we moved in was this index for. So if you pass in an array of, well, these are, let's call this value indexes. Keeping the type a little straight. Okay, you passing in an array of values. To work with it on the real arrays, the Swift arrays, we have to convert it to ints because array indexes are ints. At least that's the way we're going to use them. Here's that location that kind of slips in, and the message that needs it. Okay, so it digs up the line number for array access out of bounds. And this method was basically, well, there were a couple lines before here, but the bulk of this method was originally in the interpreter. And so we got all the computation about indexes and, multiplying them and adding and all that stuff. That is now in here and not in the interpreter itself. And then we have get input. So you can get the value at these indexes, this location if things go wrong, and it returns you a value. So this the fetch. This is more of a local one that uses an integer index, and then there's a put that takes the indexes and takes the value you want to assign there. Looks up the index and then assigns it. Okay, so this is all supporting the interpreter side, basically. The place where I added code and took it back out and added it and took it back out is the content view. And we wanted to cover the case of the variable view with an array. So we have a method array contents that only shows up if you tap the I that says show me more. Okay. And right now it's just a quick field that prints contents of the array name, and then for now just dumps out the contents. No attempt at formatting it like this. It also needs to be in a scroll view, so let's add that too. Okay. And then finally, there's this thing here. I'm taking the array, the basic array, and I'm saying, hey, just show everything. Basically, tell me how much you have. I don't think I even need to say contents here. We made that part of. Oh, no, we didn't. Yeah, well, it was part of it at one point. Okay, so let's undo that. All right. It's basically running through for every element. Well, for 0 to the number of elements. So for every, enough indexes for each element, get the value at that index. When you use a simple index, it doesn't worry about the multiplication and addition. It's more of an internal access kind of thing. Gets the simple index, linear index, pulls out that array, the value at that index, and formats it. This message, I'm not sure. Basically, we have a problem because I want to iterate over the array elements, but yeah, I don't know. We really want to iterate over the array contents, and I don't know why. Well, the question is, what's the key? And there's no unique key on those values, so they're not really great for iterating that way. For each, it wants each row to have its own individual key, like a UUID kind of key. I mean, we might be able to get the index somehow. I don't know. There's probably a way to do it, but we don't have it here. And that's I'll research it a little bit and hopefully we'll know what to do tomorrow. But we are attempting to iterate through the elements of the array and print each one out. So let's run it and do a test case on it and demonstrate that it's doing something. Okay, so I'll create an array, dim A with 10 elements. We'll assign something to A sub 3 and A sub 7. Okay, add that to the program and run it. Okay, and if we look at the variables, the end result, okay, 0, 1, 2, 3, 4, 5, 6, 7, and you can see the lack of a scroll view makes it pretty ugly. It's plenty ugly anyway, but if at least it had said A0 equals 0, A1 equals 0, A2 equals 0, and so on, I think that would be a step forward because you just have this long list and don't know what it is. Trying to get them rotating around or deriving them from the index is tricky. I did work out the math. Basically, like this array 1, 2, 3, well, you have the 0 index as well. So this is really a 2 by 3 by 4 array. If you take the index 3 mod 4, you're going to get the right value for what index 3 will be. If you take the index divided by 4 and then take mod 3, the middle index size, you'll get the value here, and same thing here. The trickiness is these products, you have to, there's no fixed size. You could have 10 indexes or 255 indexes or whatever. So we need to do it more in a loop or a recursion or something like that. But I think the math is there enough that we can work with this and get the math right for the indexes. I feel like I'm going a little bit back and forth between the int or the integer values and the value values and stuff like that. And same thing with these integer indexes, the linear index I versus the multidimensional index. So I don't know. It's not perfect, but we'll get there, or at least get closer. Anyway, that's what I've been doing for the last couple hours, and I think we'll continue tomorrow. It's the same time that I usually start, which is 10 a.m. Eastern to 12:30 p.m. Eastern, and 3 to 5:30 p.m. UTC. So thanks for joining me, even if you just caught this brief update. And tomorrow I'll remember to turn this recording device on properly, and we'll go from there. All right, take care. Good night.